Hey there, I have gotten several questions from people about the handout that's due tonight on section 2.2. And I know I've already posted the test review stuff, so we're kind of moving on. So I encourage you to keep up. And I also can encourage you to keep sending me questions. I'm trying to answer them as quickly as I can, either via Zoom or via email or via pictures. I'm trying to figure out how to do this best. So as you see here on the screen, I want to just do a few of the problems on the handout. Just one normal CDF and one inverse normal, and then one that kind of have to figure out which it is. Let me also say that the front of the sheet and the back of the sheet, one of them, it says a standard normal distribution. That you have to know that means that the mean is 0 and the standard deviation is 1. Whereas the other side, it's normal distributions where they give you other means and standard deviations. So I want to look at 8, 10, and 12, and we're going to do these three. And if you got confused on any of these, hopefully this should help as you finish this assignment. So number 8 says this. It says it's a standard normal distribution, and it says find the probability that z is greater than negative 1.16. I'm going to continue to encourage you to make a sketch each time. I don't need you to write lines at every standard deviation, but certainly put something down the middle, which this is standard normal, so it's 0. And the fact that that says a z and not an x, you need to know that those are z-scores, which means standard normal. And I want to know the probability that a z-score is greater than negative 1.16. Any negative z-score are numbers below the mean. So somewhere over here, I've got negative 1.16. Doesn't have to be crazy accurate, just on the correct side of 0. And this particular question says, what's the probability that z is greater than that? So I want all of that probability. Like, what portion of that entire curve did I shade? Clearly, it's more than a half, because at 0 would be a half. So you've got to notice that this gives you the boundary, and once the percentage is, that's when this becomes a normal CDF. So this is, I'm going to use my normal CDF. And I'll open up parentheses down here so I can fit it. I need a lower bound, an upper bound, a mean, and a standard deviation. My lower bound here is negative 1.16. My upper bound goes on forever. So that's when, in this case, I need positive infinity. So I'll just put 99999 for my upper bound. And then my mean and my standard deviation, since this is a standard normal distribution, are 0 and 1. And now I can just use normal CDF, which I will do here. Second distribution, normal CDF, negative 1.16, comma 9999, comma 0, comma 1 equals 0.877. So again, if they're giving you the boundaries and they're asking for the probability or percentage or proportion or area, those all kind of are asking the same thing. That's a normal CDF calculation. That was number 8. All right. Number 10 says find the z-score associated with the 91st percentile. Well, the 91st percentile is the score that's greater than 91% of the data. Again, if you scored the 91st percentile on the ACT, that means you did better than 91% of the people. So we're still talking z-score, so 0 is still at the bottom or at the middle here. Somewhere over here, I have a z-score, and I know it's to the right of 0 because anything bigger than the 50th percentile is going to be to the right of 0. And I am going to shade, in this case, all of this. Look at me doing my coloring like I'm in the 3rd grade. It's going to have to do. And this problem tells me that that area is 91%. So all of that area is 91%. The question is, what z-score has 91% of the data to the left of it? Well, you have to know, since this gives us the percentage and asks the boundary, that's where inverse normal comes into play. And you have to know that the inverse normal function on your calculator needs the area to the left, which this problem conveniently gave us. So I would inverse normal this. And the area to the left is, in fact, 0.91. And the mean and the standard deviation, since it wants z-scores, are 0 and 1. And I just go right to the calculator And I go second distribution, inverse normal, 0.91, comma, 0, comma, 1. I better get a number bigger than 0, like how many standard deviations above the middle? Remember, it won't be as high as 3 because that'd be like 99.7. So it should be somewhere between 0 and 3. And I get 1.341. So that's the z-score that is associated with the 91st percentile. If your score was 1.341 standard deviations above the mean, no matter what the context is, you're in the 91st percentile. All right, and then number 10, ask something a little differently. You have to figure out what it's telling you and how to label what it's telling you and how to use the calculator to answer the question that I asked. Find the z-scores associated with the middle 8% of the data. So here's 0. The middle 8%, remember this distribution is symmetric. So I'm going to draw a z-score here, call it z, and I'm going to draw another one there. We'll call it negative z. And the middle inside of this, notice I didn't need two different numbers. One is z, one's negative z, because this thing is symmetric. Well, this is fun. Hold on. Having too much fun to stop. So that's the middle 8%. Like the entire yellow region is 8%. Well, I have a percentage and I want boundaries. That has to lead you to inverse normal. But now you've got to know that the inverse normal function needs the area to the left. And I would argue that 8% is not the area to the left of some boundary. If it wanted the 8th percentile, that would be 8% to the left. But you have to know, in order to use the inverse normal function, I really need this area. Like we have to figure out whatever area that is in blue, that's the area I'm going to inverse normal. Well, we got to be real careful here with how we do some simple arithmetic. So if the middle 8% is in yellow, that means there's 4% there, and there's 4% there. That's just 8% cut in half. And in particular, if there's 4% between the boundary and 0, you have to figure out there's 46% there. And not that we'd need it, there'd be 46% there also. So let's find this boundary labeled in black, now knowing that there are 46% of the values to the left of it. So now I can inverse norm. There's 0.46, comma 0, comma 1. That's essentially find the z-score for the 46th percentile. And that's not the way this question asked it. But the middle 8% of the data has 4% on each side of the middle. And if 4% on each side of the middle, that leaves 46% in the tails, for lack of a better word. So if I inverse normal, let me find it here, inverse normal 0.46, comma 0, comma 1, I get negative 0.100. That's the z-score for this boundary. I would need the z-score. Let me change colors to purple here. I would need that one. You need to know that I could do this two ways, and they would both be completely legitimate. One would be to say, I know that this distribution is symmetric. Therefore, if the z-score on the left was negative 0.100, the z-score on the right is going to be positive 0.1. Uh-oh, got my decimal place in the wrong spot. My z-score on the right is going to be positive 0.100, and you can be done. Or if you don't realize that, let's look at this purple boundary right here. What percentage is to the left? I see 46% plus 4% plus 4%. That's 54%. If I were to inverse normal 0.54, comma 0, comma 1, I better get that positive 0.100 number. But I'm going to do it here since I came this far. Inverse normal 0.54, comma 0, typo, comma 1. I, in fact, get positive 0.100. So what I just did there was 8, 10, and 12. Hopefully that helps. Continue to ask questions. I really do want to figure out a way to best help you all. See ya.